Hey guys, this is Wellbeck speaking here from the cabinet, and today we're going to talk about something that really has been into my mind for quite a while, which is how certain companies actually, do certain features. That actually has been my interest for quite a while. So I've been thinking about Discord for quite a while right now, and there has been a feature that actually has been interested me, which is the presence. The Discord presence is quite a cool feature that you can know whenever your friend is online and stuff like that. And as someone who actually been using Discord for quite a while, like, almost a decade right now, I just said to myself, why not just implement this feature? And whenever I started actually implementing this feature, I just, came across a lot of things and a lot of approaches to implement this feature. So I just said, why not just make a video on how to make this feature? We're going to start from the naive approach. We're going to go to the professional approach. We're going to talk about the pros and cons of each one of these. So yeah, let's get started. So first of all, the first approach, which is the rest pooling one. So how does this work? So technically, your server does have two endpoints. Let me just make these. It does have two endpoints: the post, which is present me, and the get, which is presents my friends. All right. So user A just asks the server, "Hey server, can you just update my presence to be online?" All right. So right now this is actually going to be online, as you can see right here. Okay. And just give me the presence of my friends. Just give me also the presence of my friends. So it returns the presence of my friends. How does it returns the presence of his friends? It just goes to the database. Hey database, where I just want to know the presence of all the friends related to user A. Returns back this array, as you can see right here, this set, and give it back to the user. That's how it works. Pretty much simple, pretty easy. And when user B joins, it just wants to do the same thing, just asks the server to change his presence to be online, and it just goes to the database and do the same thing. Give me my friends. Okay. Give me my friends. Just goes right here. I just want to know all the friends related to user B, as you can see right here. Returns it back also, and returns it back right here. User A right here is online, as you can see right here. But user A doesn't know that user B has been online. So how can we fix this? We added a pool. All right. Not a pool as a swimming pool, like a pool. All right. We pool for 10 seconds, for example. And whenever we call, we just call the get right here just to update our friends list presence, as you can see right here. That's pretty cool, pretty easy. It doesn't actually add that much of complexity. There is no connection here in any real sense, no handshake, nothing actually to join, just a stateless request on repeat. And notice there is no broadcast, step at all. When someone changes status, that write just lands in storage. It doesn't actually it's not getting broadcasted by any chance. So nobody is told. Friend B only finds out because their own timer happens to fire, which is the poll we actually been talking about afterward, and rereads the row. So what happens if, friend isn't connected? The question doesn't even apply here. That's genuinely the one thing, this way, which is way one, we call it way one, has going for it. There is no delivery to fail because nothing is ever being pushed. And every client is fully self-serviced. He serves itself. It asks, it gets the truth as of right now. We just check in the database regardless of any other socket is doing. You know what I mean? So Redis data structure is not used here. There is no data structure. We haven't actually been using any data structures. And so what is the bottleneck here? So the bottleneck right here, if 10,000 users actually are online at the same time, each pulling every 10 seconds, that means 1,000 requests per second. That also means 1,000 SQL query per second, just so people can see a status dot. That number scales with your user count. So not with how, often anyone's status actually changes. So the pros about this is actually the simplest one. No sockets, no rooms, no fan out logic, nothing. Okay. The recipient offline problem literally doesn't actually exist right here. Nothing to break. Okay. No push infrastructure running at all. Generally speaking. The cons, database loads scales with the pooling clients. No real activity right here. And up to 10-second lag. So, when user A changes his status, user B doesn't know after 10 seconds. Okay. And constant pooling drain mobile battery from radio wake-ups. So when you design a backend application, you just have to notice that you need to take care of, the parties who actually use your service or your backend server. Because for mobile applications, actually constant radio wake-ups actually drain mobile battery itself, and falls over a roughly 100 concurrent users. So this system only handles 100 concurrent user, and that's it. It doesn't actually handle more than that. Other than that, will actually crash out. So we're gonna go to this next way, which is the eager graph broadcast, which is actually the WebSocket plus Redis one. So, which is actually the obvious next move, which is like stop asking, like open a real connection, which changes the moment they actually happen. So what really happens right here? Let's actually go through this approach right here. So what happens? The client actually opens the WebSocket, the instant it connects. The server doesn't, does something worth noticing. It doesn't just accept the connection immediately. It pulls out user entries. So what happens? User A right here just goes to the server, just asking server, hey, I'm just connecting. There is no server here, just asks the WebSocket, of course. Just goes to the WebSocket right here. Hey, WebSocket, I just want to connect. The WebSocket just goes to the database. Hey, database, I just want to know, give me the list of all the friends related to user A, returns it back. What does happen right here is joins this user to all the rooms related to user A. And that's it. So it doesn't accept the connection, immediately pulls the user's entries, friends list on their current, statuses, if whether they're online or offline or whatever, and pushes that whole snapshot straight down to the socket. It just joins, it just actually set members, it just set members in the set itself, and it just gets the friends statuses from the Redis itself, as you can see right here. And right after this, it just like emits a sync response, to the client right here. So it just tells the client that, hey, here is your friends list, and here is their statuses, and also your status is online, so you can actually be online on your client right here. That actually, hold on to like the present sync step. It's doing more, than you actually just think about it. So now a user actually, flips their status. So let's just talk about this user right here just changes his status to be like an idle or something. Okay. So what happens is just the same cycle again. When a user flips their status, the server writes new value to Redis. It just goes to Redis. Hey, Redis, I just want to, I didn't actually write this down because we're just having a set right here of all the friends, as you can see right here. And we're having a key right here, a key string for the user A status. You just name it like real Redis keys. Let me just close that. Let me just name it like presence user ID, which is UA, and we're gonna say he's just online. All right, his value is just online. His value is just online, as you can see right here. You know what I mean? And we're having a set right here for the user's friend list. So whenever the status actually changes, the Redis just goes and does the same thing, just asks for the friends list and broadcasts to all of these users. So broadcasts this change to the n amount of friends that I have in my socket right here, my Redis set right here, even though they're offline, which is the problem, as you can see right here. So it actually pulls it pulls the entries, the friends list, and it walks the entries friends graph and fires an individual push at every single one of them, as you can see right here. And emit to user is really just emit into like the socket IO room and named after the friend's ID. This loop runs in, identically, whether the friend is started in the screen, background on their phone, doesn't actually have the app at all. So it doesn't even care about the status of this user itself, like what he's doing. Is he actually like, does he need actually to know the status or not? So what happens if the user isn't actually connected? Targeting an empty room is silent. Like there is no operation at this socket room right here. Socket doesn't actually error, doesn't actually queue, it doesn't retry. There is nobody in the room to actually hand this event to, as you can see right here. And call just returns like nothing went wrong. The updates is gone. Like if there is if there's something actually went wrong, like nobody actually gets the update. This is only okay because process sync, which is the response we actually been talking about stiff from before. The Redis write happen regardless of who was listening. So when that friend eventually actually reconnects, like on connect or something fires fresh, ready rereads everyone current value and they land on the right final state. That just never saw the live transition. If someone went online and back offline in 30 seconds, a friend was disconnected, the friend's resync shows offline and never actually learned it happened at all. Nothing is broken out. Nothing is preserved either. So way two, which is the graph we've been talking about right here, promises eventual correctness on reconnect, not delivery on every event. So this is actually the problem right here. Also, the Redis structures we actually been using, we actually viewed set, as I said right here. We're just having friends set right here with user ID. So we're having a set friends. Let me just write the key of the friend set. It's just gonna be like that, friends. And with the user ID, we're just gonna have like all the list of friends right here. Also, we have a string, which is the presence user ID we've been talking about. It does actually care the state. And the bottleneck right here is the fan out with scale, which is the social graph. So how many friends I have? If I have like 1,000 friend, that does mean that I'm actually broadcasting to 1,000 user. That doesn't matter if they are actually online or not, even if they are not even opening the website itself or opening our mobile application. I'm just broadcasting them no matter what, which is bad because right now I'm just gonna have like CPU spikes and bottleneck. I'm just gonna overload my WebSocket as well, which is pretty bad. And reconnect correctness is automatic. So we've been talking about the bottleneck right now. So the fan out scales with your social graph, not with who is actually watching, which is actually what we've been talking about. So if I have like as I said, like 1,000 users, that means like 1,000 socket emits on a status flip, and most landed on empty rooms or nobody's actually watching this room or actually connecting to this room, listening to it. So now picture a creator with 500 or 500,000 followers, for example, going online. Same code path emits like 500,000 WebSocket event, which means like 500,000 WebSocket events, like 95% of them are actually wasted. So all hitting the server in one spike, which means crash out for sure. And so what is the pros and cons of this solution right here? Genuinely, so the pros first, genuinely real time. When I just benchmarked this, it ended up with like pretty much just sub 50 milliseconds, something like that. Once the client is connected, reconnect correctness is automatic via the full presence sync. So when the user actually every couple of seconds just syncs, this user right here every couple of seconds just syncs, asks the server to sync him or stuff like that, to sync the snapshot. Removes constant pulling. So right now we don't have to pull for 10 seconds or stuff like that. There's no latency. As you can see right here, Redis absorbs the the connect time and change time, reads it instead of hammering the SQL itself. So the Redis right here just caches the friends and stuff like that, which is pretty cool. And the cons, which is the fan out cost, which has actually been talking about, the to friends or followers count, not the actual viewers. The celebrity problem we've been talking about. Roughly 95%, pushes land nowhere. Useful, pure wasted network traffic, as I said before. And also, live transition can vanish entirely if the recipient wasn't connected at the exact instant. You know what I mean? And ceiling roughly, so the limitation, how many users can this system actually can handle, up to like 10,000 concurrent user. That's actually going to be the max of it. Other than that, it will crash out for sure. So the way 3, which is the Discourse style one, which is the final solution that we actually ended up with, which is have an HTTP hydration. So phase one, the wave 3 actually has two phases, which phase 1, which is the REST hydration, and phase 2, which is the scope subscription. So what is the phase 1? Okay, so how does phase 1 work? So the phase 1, how does phase 1 work? Phase 1 works like that. User A just asks the server to get his friends, or get his DMs, for example. The server returns back the friends, just like that. The server, the client uses these IDs of the friends he's looking at right now. He just wants to know like a couple of them, for example. He just sends these to the WebSocket. Hey, WebSocket, okay, I just want to know these user IDs. All right, just like that. I just want to know these user IDs. Okay, so phase 2 only wants a specific piece of UI actually mounted on the screen, as you can see, like that. The friends sidebar or a DM list or a member panel does the client tell the server, hey, socket, I just want to know the presence of all of these. On the server, that subscribes call joins joins the user to the rooms named with all of these user IDs. IDs. So the rooms can be like that. The room will be presence with the user ID. Okay, that we actually have it in this list right here. So we join this user into a room for each user ID he has sent right here. So he's watching these users' presence. Okay, so that's actually how it works. So we're saving a set right here into the database. This set right here is going to be like a presence. This is actually going to be presence. This is actually going to be presence UA, and we're going to have like, this is actually like a hash, and we have a set right here, which is going to be sockets UA, which is actually going to be a set of all the users, which is actually going to be a set of all, the user, all the sockets that this user actually listening to. So later on we can, broadcast. And so right after this returns, right after he actually just asks the server, hey server, I just want to connect to these user IDs, it returns him back a fresh snapshot of the statuses of all of his friends, and it gives him, hey, you're now online, and here is a list of all your friends, whether they're offline or online or stuff like that. That's actually pretty cool. So what happens when user B actually joins? When user B actually joins, it does the same thing. It's pretty much the same. It just asks the server, just go through the whole cycle. But the thing here, user B is actually friend with user A. So he sends, I just want to listen to user A. But user A is already online, and he's actually in a channel. There's a room named presence user ID, which is the user ID of user A. So right now, it broadcasts. First, it goes to broadcast to user A, hey, user B is online. And user B just gets back that user A is online, and he is already online, as you can see right here. That might sound complicated to you. We're just going to talk about, I'm just going to show you like a presentation of how this actually works in real time, because I have a presentation for you right here, a real application. I'm going to explain to you how does this work, okay? So here is a real WebSocket, as you can see right here. So the first thing, we just connect to the WebSocket. This is a session ID, pretty cool. Right now, I just connected. Okay, I just tell the WebSocket, hey WebSocket, I just want to know the status of this friend list right here. These are my DMs, as you can see right here. So the WebSocket just responded to me, just saying, hey, here is the list of here's the statuses of all your friends. As you can see right here, they're actually offline. All of them are offline, so I rendered them as offline, as you can see right here. And here is your status. Let me just change my status right here, because whenever I just leave the mouse for quite a while, my status actually changes to be stale, idle, as you can see right here. So I sent to the server, hey, my status is idle. So the server just told me, okay, your status is idle and it's been saved. When I changed the mouse, I just told the server, hey server, I am online right now. The server just told me again, oh, okay, you're now online. That's pretty cool. So let me show you the broadcasting between multiple users, as you can see right here. Let me just close this. Let me just refresh this page, open a WebSocket here, refresh this, refresh that, just to get a request, the first couple of requests. Okay, so let's actually look at the WebSocket right here. As you can see right here. So right now, it does this have the same thing. I receive that the user ID is now idle, as you can see right here. If this user right here, this user, which is on the left right here, if I just change this and I cleared this right here, as you can see, look at that. Oh, it does notify this user, hey, this user now is online, as you can see right here. And when I go here, let me just clear this cache here. When I go here and I change the status here, it tells this, hey, this user is online. So this is actually like the case one. This is actually like how it works. It's pretty, it's pretty neat actually, just to, think about it. It only broadcasts to the users that are actually subscribed to you. You know what I mean? Nothing more. You know what I mean? So the case one, the person whose status changes is offline, nothing to broadcast in the first place. You know what I mean? No open sockets means means presence naturally actually goes offline, as you can see right here. So the presence of offline or online is actually being handled by the WebSocket lifetime. So whenever you connect, you're being turned online. Whenever the WebSocket is disconnected, you're offline automatically. So there is no handling of that. The WebSocket actually update request is just like updates my status to a certain thing and to certain status and stuff like that. And there is case B, which is whether isn't connected or hasn't subscribed yet. So the same silent no op, as way 2 we actually been talking about. So it made to a room on empty room does nothing. So you will not actually broadcast to anyone because no one is actually listening to the room itself. It leans on phase 1, return running again, from scratch. The next time the person opens the app, the plain REST call totally actually independent, independent of socket state, reading the current ground truth. The subscription that actually follows the purely additive. It just keeps an already correct picture live going forward. That's it. So the Redis data structure used, we actually used right here, as I said, we have used sets and we have used hashes for the user state itself, and we've used set for the, how many users are actually subscribed to your room. And and let me just talk about the pros and cons of this one, which is on wrap up. So the pros and cons of this one, the fan out capped by actual viewers, so not by graph size. So someone with 100K followers and 200 watching, only 200 messages actually have been sent. So there is no CPU spikes, there is no wasted bandwidth, nothing of that. And Socket.io collects garbage collect all of the the connections automatically. So the room memberships and all of that. So on a tab close, so nothing actually leaks, no manual Redis tracking or anything like that. So whenever the socket is actually disconnected, the room are closed and everything is actually clean and the status goes offline. Everything goes automatically. You don't need to handle that by Redis or something like that. And also correctness never actually been on the socket state, even on a first plane. And also reconnects rehydrate with 0 stale data window. So right now, you don't need to load any data. It just like tells you, hey, these are the data of the users that you're actually looking at right now. And if you ever just had another friend, let me just open a new friend right here. Okay, now I got a new friend, Sarah Drancer. I don't know what's her name. Okay, as you can see right here, the states actually change automatically. As you can see right here, she will be idle right now. If I changed her status to be disturbed, do not disturb for quite a while, it will actually change again whenever she changes. It works pretty cool, And what are the cons here? So the cons right here are just, not quite that much. So more moving parts, which is the thing right here. You have WebSockets, you have Redis, you have a lot of stuff actually moving right here. And they have to be in sync. And so you have to make sure that none of these servers actually will be off. So client has to manage subscriber and unsubscribe life cycles on new mounts. So for example, if you're using React or stuff like that, you have to have a hook for something like that, just to make sure you're not re-rendering or stuff like that, or reconnecting a couple of times. And also, client still has the same silent no op if nobody is listening yet quirk as way 2, just recovered differently, as you can see right here. So this actually can be enhanced, and I just left the door open. I just did a little bit of thing right here. I'm satisfied with the solution that I have right now. I think it can scale well, scientifically right here. We don't know the applicant because many times we have things, that are scientifically working okay. They can work, they can scale, but in real production, things can happen differently. But yeah, let me know what you think about it in the comments, and see you in the next one. See you.